question asks us about seals and how seals swim. And this is actual tracking data for a seal. And the seal took 4 minutes to descend 360 meters below the surface of the ocean while it was moving 920 meters horizontally. And we're asked some questions about this motion. Well, to prepare, let's draw a picture of the motion. And then let's think about what we're expected to answer. Okay? So the seal starts here. And it moves 920 meters horizontally. Meanwhile, it dives a distance of 360 meters vertically. Okay? So the seal moves 920 meters horizontally, and it drops 360 meters, but it does this on a straight line path. And the straight line path goes like this. So this was the actual motion of the seal. This distance d is how far the seal moved. And that's one of the things that we're asked to find. We're also asked to find the angle of the dive path below the horizontal, which is this angle right here. Finally, we're asked to figure out the seal's speed in meters per second. The distance is this distance d, the time is 4 meters. Before we start, I want to do a quick assessment and note this. It takes the seal 4 minutes to go this distance, and I'm guessing this distance is going to be about 1,000 meters, okay? So 1,000 meters is about a kilometer. If you move a kilometer in 4 minutes, that means you're doing a 5K, 5 kilometers, in about 20 minutes. That's a pretty good clip. So I'm expecting the seal to be moving at a speed that corresponds to a pretty decent running speed. And we can use that to check our work when we're done. But now we're ready to do some solving. Okay? We're going to start with A. What is the angle of the seal's path below the horizontal? Well, if I look at this angle theta, this triangle is a right triangle. The opposite side is 360 meters. The adjacent side is 920 meters. So the inverse tangent of the opposite over the adjacent, 360 meters over 920 meters, is equal to theta. Okay, that's going to give me what theta is equal to. That's one of our basic trig relationships. So if we compute what we get for theta, it's this. It's 21 degrees, and that seems reasonable. Okay, this side is 360, this side's 920. I expect this angle to be less than 45 for sure. 21 degrees seems reasonable in terms of my picture. How about the distance d? Okay, how about the distance d? Well, this is a right triangle. And so the hypotenuse is just equal to the square root of the sum of the squares of the other two sides. So it's 360 meters squared plus 920 meters squared. Square root of the whole thing, that's something we can easily compute. And if we do that, we get 988 meters. By the way, I've kept an extra significant figure here because this is an intermediate stage in the calculation, because in the next step, we're asked to find the speed. So 21 degrees travels a distance of 988 meters. That's our part A. Part B. Part C is the speed. The speed is 988 meters in a time of 4 minutes. But I'm just going to put in what this time is in seconds, okay? And 4 minutes is just equal to 240 seconds. And so I'm just going to cut to the chase, and I'm going to put that in. 988 meters in a time of 240 seconds gives me a speed of 4.1 meters per second. That's my answer to part C. Now let's do an assessment. Okay? We learned in chapter 1 some kind of like order of magnitude estimates that we could make. And one of the things that we said is that 1 meter per second is approximately equal to 2 miles per hour. So if the seal is moving at 4.1 meters per second, that corresponds to a speed of about 8 miles per hour. That's certainly faster than I can run. That's a pretty good clip. And that seems like a decent speed. That's about what I would expect it to be. And so our glide path, this angle matches our picture. This number seems reasonable just in terms of looking at the triangle. The final speed that we calculate matches our original estimate. We expected it to be something like a reasonable running clip. So our net result is this. Our answers match our understanding of the way the world works.